Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 3264. Final array state after k multiplication operations 1. This question has been asked in Amazon recently and it is based out of Heap concept. Also it is marked as easy. Now let's have a look on the problem statement. Here we are given an integer array nums, an integer k, and integer multiplier. So 3 inputs are given to us. And we need to perform k operation on nums. So this is the array given to us, and this is one integer multiplier, and this is another integer k. K represents the number of operation we can perform over this array. And what is this operation? Find the minimum value x in nums. If there are multiple occurrences, find the one which is appearing first. So the operation is that in every operation you have to find the minimum value from this nums array. Let's say for the first operation it is going to be 1. If you have picked this minimum value, then replace the value with x into multiplier. You are picking the minimum value which is 1. You have to replace this value with 1 into 2. This is our operation. And this operation we have to perform k number of times. And after k number of times, whatever is the state of our array, you have to return that. Final state of nums after performing k operation. So this is our problem statement. Let me summarize it. Given are 3 values, nums array and integer multiplier, integer k. K number of operation we have to perform. And what is the operation? Pick the minimum number from the nums and multiply it with a multiplier. So if the value is x initially, x will be replaced with x into multiplier. And just return the final state of the array after k operation. So this is we have to return. Now let's try to figure out the answer on this example. Here, this is the array given to us and this is k number of operation we are going to apply, and this is multiplier. So in the first operation, we have to find the minimum element. What is minimum element? Minimum element is 1. So 1 will be replaced with 2. 1 into 2, which is 2. So this is the state after one operation. 2, 2, 3, 5, 6. In the second operation, pick the minimum value which is occurring first. That is going to be this 2. And this 2 will be replaced with 4. 2 into multiplier. And in the next operation, third operation, we are going to pick 2. And 2 will be replaced with 4. Now the state is 4, 4, 3, 5, 6 after 3 operations. In the fourth operation, minimum would be 3. 3 will be replaced with 3 into 2, 6. And this is the state after 4 operations. In the fifth operation, what is the minimum we are going to pick? We are going to pick this one. And this is coming first. This will be replaced with 8. So the final state of the array would be 8, 4, 6, 5, 6. This is the state we have to return. This array is our answer. Okay. I hope you are clear with the problem statement, that pick the minimum element and replace it with the element at that index into 2, into multiplier. Now let's have a look on the approach. Firstly, what can be the brute force in this case? What we did when we were solving this example, we are picking the minimum element. In every operation, we are going k times. It means we are doing an iteration k number of times, and in every iteration, we are picking the minimum element from the array. And from that minimum element, whatever is the index, let's say minimum element is that index idx. So that value will be replaced with 2. This much we are doing. So first loop for k values, k operation. Second loop, finding the minimum element from these n arrays. And whatever the minimum element we find, and we are able to replace it with the new value in an order of one time. Just some operation. This is order of k time. This is order of n time. Every iteration. And this operation is order of one time. And these are nested loop. So overall time complexity would be order of k into n. What about the space complexity? We are not requiring any extra space. So brute force is going to take order of n square time on average, if both the values of number of operations and number of elements can go till n. So our brute force gave us quadratic time solution. Now let's try to think of a optimized way. What can be the optimized way? First of all, we definitely have to apply 5 operations. In every operation, we need to pick the minimum element among this array. And apart from that minimum element, we are not concerned about any other element. Every step, just give me the minimum one, and I'm not concerned about any other element. So in this particular case, we are going to use min heap, because min heap will be giving us the minimum element. Whenever we have to pick an element, we'll get the minimum element in order of one time. Okay. And in the heap, when we insert an element, so the time complexity of that is order of log n. So when we have to do the operation, let's say when we are doing the first operation, in the first operation, we require the minimum element. It means before the first operation, we should have all the elements in my heap. I will insert all the elements in my heap, and when it is the first operation, I will pick the minimum one. Minimum one is 1. And I have to update its value to 1 into 2. To update the value, I would require its index. So along with the value, we also need to store index in the min heap. So min heap, we can store an array where the first element can be value and second element can be index. So this is the item we are storing in the min heap. 0, 1, 2, 3, 4. Initially this element would be at the top of the min heap. I will just extract this element, update the value at this one index and put it back into the min heap. So in the next operation, I will get the minimum element. Before performing any operation, this would be the state of my min heap. In the min heap, I am going to extract out the first element. So this 1, 1 will be removed from the heap, and instead of 1, 1, what I am going to insert? 2, 1. Value is replaced with 1 into multiplier. So this is added to the min heap. Now this is my min heap, and whatever is the minimum element, who is occurring first? This minimum element, but it is occurring first. We should not pick this one. So the ordering in the min heap will be based out of value. If the value is same, then index in the increasing order. So this is the main part, that you are initializing min heap and you are putting the sorting function. Sorting function, you are sorting on the basis of value, and if the value is same, you are sorting on the basis of index, so that if the two values are same, you are picking the values which is occurring first in the array. This much we have to do. Using a heap data structure, you will be able to optimize the time complexity. Let's say how much we have optimized. We are having n number of items in the nums, and we are having k operation. Initially, we are putting all the n items in the min heap. So time would be log n. So this is the time complexity for that. And in k operation, I'm polling the minimum element and inserting the updated value again in the array. So that is going to be k log n operation. This is not nested. Firstly, I did this, and then second, in my loop of k times, I'm doing log n operation. So in total, what is the time complexity? On average, if you want to say, you can say n log n is the time complexity of my approach. And what about the space complexity? Here we have introduced a data structure heap to optimize our result, and heap can go till order of n as per the size of the input. So this will be the updated time and space complexity. In the previous approach, brute force, we were getting k into n. That was quadratic. And this is n log n, which is better than n square. Let's code this approach. Here first of all we require a priority queue which is going to hold that value of at ith index along with the index. Priority queue of integer array pq, new priority queue. And this priority queue is going to take a lambda function. This is going to be our custom sort function. And first of all we need to see if two values are same, we will be sorting on the basis of index. If a0 is equal to b0, in that case we are going to be sorting on the basis of index in the increasing order, a1 minus b1. Otherwise sort on the basis of value, a0 minus b0. Now my priority queue is initialized. Let's capture the size of this nums. And now I will be adding all the elements from nums to this priority queue. For I equal to 0, I less than n, I plus plus, pq dot offer new integer array. And in this integer array, first item let's keep it as value, second let's keep it as index. Now what I have to do is apply operation k number of times. So while k minus minus greater than 0, while k does not reach 0, I'm going to do some operation, and after that operation whatever is the state of nums you have to return it. In my priority queue I have integer type of element, let's call it t, is equal to priority queue dot offer. This is the entry with the minimum value and the minimum index. You have to change its value. Firstly let's capture value is equal to t0 and int index is equal to t1, and its value should be updated to, note its value in the nums array. Nums at index I should be equal to previous value into the multiplier. Now the value is updated and I have to offer this new entry again in the priority queue. Priority queue dot offer. Here it should be poll. I am polling the minimum element and then offering the updated one. New integer array, and the value is again nums of I, and the integer is I. So this is going to update my nums array k number of times, and after that I just have to return the state. Okay, I think that's done. Let's try to run over sample test cases. Sample test cases are passed. Submitting the problem, it got submitted successfully. I hope you have understood the problem. If you have any doubt, you can comment down below. Thanks for watching. Bye bye.